Alright, Physical Science, Lab 2.1. Gonna talk about evaporation and temperature. I've got all the supplies all set out. Got to do this for a couple students who missed class on Wednesday. So we're going to go ahead and do the same thing that we did in class on this past Wednesday. Alright, we'll read the intro together. In this course, we will spend a great deal of time learning about the physical environment that surrounds you. Where better to start than air itself? After all, air completely surrounds you. Even though you cannot see it, you know it's there. You feel it move when there is a breeze and you breathe it in and out continuously. Since it is such an important part of our everyday experience, it deserves some special attention. Now you have probably learned a few things about air already. Nevertheless, I am sure you have not studied air in detail with which I will present it. Do not turn off, therefore, just because a few of the subjects discussed below sound familiar. There is a lot to the subject of air, and even though we will study this fascinating mixture of gases in some detail, we will still only scratch the surface of all the things that can be learned about the air that surrounds you. The air and humidity. In order to begin our study of air, I want to look at its composition. Before I can do that, however, I need to tell you about a very important concept in the study of air: humidity. Humidity is the moisture content of air. No matter where you are on the planet, the air that you breathe probably contains some moisture in the form of water vapor. This moisture affects you quite a bit. You see, your body has an ingenious means of cooling off when it's hot. God has designed you to sweat when you are too warm. When you sweat, water is released onto your skin. This water, once exposed to the air, tends to evaporate. Well, the process of evaporation requires energy, which is supplied by the heat on your skin. As a result, when your sweat evaporates, it takes energy in the form of heat away from your skin. Since the evaporation of sweat takes heat away from your skin, the net effect is that your skin cools down. Isn't that marvelous? Your body has been designed with its own cooling system. When you get hot, your body releases sweat that evaporates from your skin. In the evaporation process, heat is removed from your skin, cooling it down. You know what's even more amazing? This cooling system in your body is self-regulating. You don't sweat when you are cool or comfortable. You only sweat when you need cooling off. Think about that for a moment. It took human science nearly 3,000 years to come up with a thermostat-regulated cooling system. Nevertheless, the human body has had one since it was made. This is just one of many incredible design features we see in nature. It is a stirring testimony to the fact that we are fearfully and wonderfully made, from Psalm 139:14. To see this effect perform the following experiment. Alright, so we have a glass. We've got 2 cotton balls, some tap water that I've actually had sitting out for quite some time so we can have it reach room temperature. Supposed to use safety glasses, but I don't think that I'm not going to say that we don't need them, but I'm not going to use them in this experiment for this video. We've got a bulb thermometer and a small piece of Ziploc bag, or you could also use a square cup from a trash bag. Alright. Everyone knows that water left in the presence of air evaporates. Well, it turns out that the process of evaporation actually takes energy. Thus, when water evaporates, it cools the surface it is touching. You will see this effect in this experiment. Alright, so I'm just going to walk you through what we did in class. We followed the directions. We filled the glass, let it go to room temperature, Let it sit out for 15 minutes. Let's see. While you're waiting, I already did that, so the thermometer has actually been out of the tube and on the plastic for quite some time now as well. The hard part about this is going to be actually seeing where that is. So the first thing we're gonna do is actually record the temperature right there, and all those little notches are in increments of 2. So it looks like it's about just shy of 74, but we're gonna call it 73. So that's pretty close to 73. Let me see if you can see that right there. It's almost 70. Oh, 73. We're going to call it 73. Alright, so the next thing we're going to do, we're going to get these soaking wet, the cotton balls, and we're going to drain them out as much as we can. We're also going to need to record that 73 in our lab book. Alright, for the lab write-up, and then we're going to spread these out and put them right around this. And what's going to happen is as this evaporates, it's going to take the heat away from there. So let's go ahead and record those results in our table. So we got temperature 1, thermostat on the plastic was 70. We'll do like 73 degrees Fahrenheit, but almost 74 degrees Fahrenheit. Alright. And now we're going to go ahead and take a break and call this part 1. And I'll go ahead and get this uploaded to YouTube. So this is just part 1. I'll come back for part 2 after about 5 or 10 minutes have passed.